Hello, this is Lab 1 for the Intro to Physics class in Coursera. What our research team wanted to know is, can we predict an object's future position utilizing Newton's second law? Let's review. In Newton's second law, we begin by looking at the system's initial conditions, or initial velocity. We also need the system's mass and the delta t, or the change in duration of time during our measurement. Then we take into consideration all the interactions, or the net force, acting on the mass. And with these factors, we obtain the final velocity. If we take the final velocity and times it delta t and add the result of that operation to the initial position, we obtain the final position, which is our predicted position. So, using Newton's law, we see that all that we need to make our prediction is the initial velocity and the initial position of the system. To answer our research question, we analyzed the motion of a soccer ball on video in the tracker software, and the ball appeared to be moving in constant velocity in a Cartesian coordinate system where the x-axis is horizontal and the positive direction is towards the right, the y-axis is the vertical, and the positive direction is up. The z-axis is positive towards the screen. To begin, as we just saw, and we can see again, we obtain a frame-by-frame track of the motion of the ball, and this way we captured the position of the ball at different times. Once the ball position motion was captured, the tracker software automatically plotted into a position versus time graph and a table all the data, as in here and here. With the data position from the video, we are able to calculate the initial data for the model in vector component form, as seen recorded here and here. After calculating the initial vector component data from the ball's motion in the video, we plugged in the vector component data into a Python script, seen here highlighted in yellow and green, and we constructed a computational model of the ball's motion. As seen in here. When we ran the model, the actual script, the model of the Python in the model of the ball in Python looks similar to the motion we observed in the video. This model constitutes our predicted motion of the ball because, as Newton's second law states, it took the ball's initial conditions from our video experiment observation to calculate the future positions of the ball. And it did so by making many small predictions into the future over and over again. Next, we compared the measurements from the experiment observed motion in video to the model's predicted position plotted in a time versus position chart. Here, the positions of the ball's motion from the observation in the video are represented by the blue line, and it is labeled experiment position. And the positions of the motions from our computational model are represented by the red line, as seen here and here. Our results. The animation of the ball's motion in our model is visually similar to the motion of the ball in the video. Plus, in our chart, the experiment position and the model prediction lines follow comparable paths. We can say that our experiment shows that with Newton's second law, we can predict the future position of an object if you're able to calculate the object's mass, the external forces interacting with it, and the duration of time those forces are acting on it. As a critique of our experiment, we could make some adjustments to arrive at an even more accurate prediction of the ball's future position by accounting for 1. Unidentified forces acting on our system, such as gravity and friction, and 2. Experiment data was not precise perhaps when making the marking of the ball in each video frame, as each mark was perhaps not always centered, leading to a variation in the chart's plotted blue line. Thank you.